Hello guys, welcome to the third problem in Project Euler. This is problem number 3, largest prime factor. The prime factors of 13,195 are 5, 7, 13, and 29. What is the largest prime factor of the number? That one. Okay, before we get started, we need to know what a prime factor is. A prime factor is a number that only 1 and itself go into, such as 5, 7, 13, and 29. All other numbers are considered composite, with the exception of 1. 1 is referred to as a unit. So what we need to do here is find the largest prime factor of this number, which is too large for me to think of right now. So referring to a program, we obviously need a method to determine if a number is prime or not. And second, we need to find the factors of this number. So let's get started. Let's start out by making our method signature first, which would be public static boolean is prime, and then long num. So how are we going to test if a number is prime? Well, if a num is less than 2, it's not prime, so we want to return false because 1 is a unit. If number equals 2, return true because 2 is prime. If num modulus 2 equals 0, that means it's even, and if it's even, it's definitely not prime. Otherwise, we want an divisor to equal 3. Divisor is less than, let's see, math.square root, yeah, the square root of the number, divisor plus equals 2. Okay, we're setting to divisor to 3 because we checked if all numbers were even right here. The reason we're going to the square root is if you take any number, if you take the square root of that number and go up to it, actually that should be equals, sorry, if you take any number and go up to the, either less than or equal to the square root, you can determine if the original number is prime or not. And we're plus equaling 2 because we're checking all the odds, just we already checked the evens. So if num mod divisor equals 0, return false. And down here, return true. We can do this because once it reaches here, it will automatically leave the method. So we don't need to say, like, else or anything. Right, now since we have the method stated, we'll just state what it does up here. Determines if a number is prime. Number to check. And it will return a boolean true if and only if a number is prime. So let's check that number again. The number we want is that. Let's copy that. We're going to put that into a final variable because that number will never change. So final long high equals. Okay, if you did an error like this, then put either a lowercase l or a capital L after the number. And this is explicitly telling the compiler that this is a long. Convention is to use a capital L because a lowercase l looks too much like a 1. After that, you want a long, 1 too far down. long divisor equals 2. And that's just starting the divisor at 2. So what we're going to do is cut this in half initially and check if it's prime. Yeah. Okay, sorry. So, while true, normally you don't do this, but we want this loop to continue running until we reach something that meets the condition. And whenever I did this the first time, I had another variable, and the variable was long highest so far. And this was to check, like, if there were more than one prime factor, it would check the highest prime factor. But I quickly realized that there is only one prime factor of this number. Besides, like, 2, of course. And I shouldn't say there's only one prime factor. It's going from the top down to check the prime factor, so having that variable high so far is kind of redundant because it will always be the first answer. Sorry for confusing you. So we want a temporary variable equal to high divided by divisor. And this is just getting like 2 divided, or this number divided by 2. So it's getting the quotient. So if high modulus, is it high modulus temp? I think so. If high modulus temp equals 0, and is prime temp system.out.printf the highest prime factor is %d%n. And we want the variable, or the argument, to be the temp variable. And we want to break out of the loop as soon as we find it. So this will display the highest prime factor. This is saying if this temporary variable, if this high is divisible by this temporary variable, then it is a factor of this. If that number is also prime, then that will be the highest prime factor. And if this doesn't occur, we want the dividend to just go up. Yes. So, if we run this, it's 857. I think that's the right answer. Yes, it is. This is the correct answer. Unfortunately, it does take 2 seconds. If any of you have a faster solution, I will gladly post it in the description down below and give you credit towards it. This is my implementation. I'm not too sure how efficient it is. I thought it was pretty good on my first try, but thanks again for watching, and tune in for the next video, Project Euler, question 4. Thanks for watching.